Hello and welcome to another daily Leetcode challenge. Let's begin question 207, course schedule. There are a total of num courses you have to take labeled from 0 to num courses minus 1. You're given an array of prerequisites where the prerequisite of I is equal to an A, B. So it's a 2D array. Indices that you must take indicates that you must take course BI first if you want to take course A. Okay, so we're given a number of courses labeled from 0 to num of courses minus 1, and a 2D array representing prerequisites within those courses. For example, a pair 0, 1 indicates that you have to take course 0. In order for you to take course 0, you first have to take course 1. So, okay. Return true if you can finish all courses, otherwise false. So return true only if you can finish all of 0 to num courses minus 1 courses, otherwise return false. Okay. So, right off the bat, there's a video that I made yesterday that pretty much has an identical sort of setup. The video there solves a question called find all safe nodes. And a safe node is considered to be a safe node within a graph if it eventually leads to a terminal node. Terminal node is one where it has no outgoing dependencies. And this question right here can be structured the same way. We can say that a course with no prerequisites is the terminal node, and then any course that a safe course is one that which prerequisites are other safe courses or terminal courses. Let's call this course. Okay, so given that we can remodel this question with the same way that we solved yesterday's question, let's first create the data structures that are going to be used here. The data structure that I want to use to represent prerequisites is going to be a dictionary. So I'm going to have a prerequisite dictionary, and I'm going to make that a default dictionary with a set as my default value. And I'm going to say for p in prerequisites, I'm going to say prerequisites dot okay, so this is a directed graph, and my parent node, my pointing to node, is going to be the prerequisite. So the class that I want to take is going to be class that I want to take is 0, and the prerequisite is p1. Okay, and once I've added this, once I've created this prerequisite graph, let's actually just call it a prerequisite graph. Let's print this and make sure that we're getting exactly what we want. What we should be seeing is a key value data structure where the keys are the classes and the values are their prerequisites. And there could be multiple prerequisites for a class, but let's see, we have a data structure where in order to take 1, you need to take 0 first. Is that for example, indicates that to take course 0, you first need to take course 1. This is wrong. I wanted to take course 0, you have to take course 1. I see. So this was messed up. 0 is the second value. The class that I wanting to take is in the first value. So it's very important to be gradual about these things. So okay, now we have the correct setup, the course, and its set of prerequisites. And so now that we have the setup, let's do the same deep first search, modified deep first search that's going to find all of the safe courses. The safe courses being the ones that that we can take eventually after a certain number of years or whatever. There are situations where we're not going to be able to take a course if there's a loop, which is the same problem that was in the previous question. So let's define our DFS with a node, and let's do the same setup that we need a safe course, a dictionary, and we need do we need anything else? I don't think we need anything else. The safe course is going to be, or a possible courses, available courses, or how would we call this? Maybe courses, doable courses. We're going to be naming them either true or false. If they're doable, the value is true. If they're not doable, the value is false. So if doable courses node if node in, then we're just simply going to return doable course node. Else, we're going to try to see if its children, if its prerequisites are at least doable as well. So for that to be true, we have to set doable courses of this node to false to make sure that if there's a loop pointing from its prerequisites back to itself, then this is going to be returning false. And then for neighbor in our prerequisite graph, if neighbor in, and then DFS. Oh, no. If not DFS neighbor, then return false, meaning that this is the only case where we're 100% sure that the course that we're looking at right now, which is represented by this neighbor course, this is the only case where we're sure that it's not going to be doable. And then assuming that this doesn't get executed, we are assuming that this false isn't going to be returned. We're saying that this is true and returning that our current course is true, is also doable. And then the same thing that we did before, also in the previous question, for course in. And now we need all the available courses. Do we have a list of that? Let's have here, how should I do this? Courses, let's have this set be here, and then for courses add the target. Oh, no. Our courses are the number of courses numbered from 0 to num courses minus 1. So actually, course in range num courses, we're going to say if DFS course, if not DFS, return false, otherwise return true. And that's it. Let's see how well this runs and if all the things are passing. It seems like they're not. Let's see what's wrong. Interesting. So so it seems like one of these courses is being said to return false. One of these courses is returning as false, although there's no loops, and yeah, there's no loops. So okay, let's make sure that we're doing the right thing at least. So we're printing out 0 and 1. Printing out 0 and 1, and in our zero and 1, we're printing out 0 and 1. We're printing out 0 and 1 in the first and the second case. Okay, so what is wrong here? Well, to me, it seems like I've done everything correctly. Prerequisite graph. Unless, I mean, here, I'm not looking at the prerequisites actually, so this might have been the issue. I made a mistake here where I wasn't looking at the prerequisites for the node that I'm currently looking at. I was looking at all the values, all the key values, which is incorrect. Let's submit this. Okay, awesome, and we are, and we're beating 93%, which is a great thing to, just great for us. And this is pretty much the identical code to what was happening yesterday, with the exception of us having to create this intermediate data structure doable courses. Now, one more time, I'm going to go through what each of the portions of this code are. Initially, we create a directed graph where the key is a course and its value is a set of prerequisites. Now, this is a directed graph because it's clear from where to where the path lies. And from here, it's going to be from course to prerequisite. Now, recursively, I can define a safe class as one that I can safely take if I have all the prerequisites finished to it. An unsafe course, an example of one would be one where there is a loop, where for course 0, I need to take course 1, but for course 1, I need to take course 0. And so what this now does, the DFS algorithm, deep first search, is makes sure that there are no loops within the graph. And if there is one, we return false, and else true. And so with that, I want to say that please use this and feel free to like and subscribe, and I'll see you on more videos later. Bye.